Hello everyone. In the previous video we have learnt what is variance and what is standard deviation. And the formula for variance was sigma square is equal to sigma xi minus x bar whole square divided by n. That was the mean of the squares of the deviations from mean. And we have applied this particular formula to find out the variance and the standard deviation of the data given to us. Applying this mean. But sometimes, suppose the mean is in decimal, 2 places or 3 places of decimal, or it is non-terminating value, then we are not to apply this because this becomes a bit difficult in calculation. So we are finding another formula where we are not to apply the mean. What we can do in that? Let's see here, the formula for variance is sigma xi minus x bar square divided by n. Or we can write 1 upon n sigma xi minus x bar whole square. If we apply the formula of a minus b whole square here, will it become 1 upon n sigma xi square minus 2 into xi into x bar plus x bar square? Is it or not? Can we write this as 1 upon n sigma xi square minus 2 into x bar, because x bar is a numerical value, it's a number, into sigma xi plus x bar is a number, square of x bar if we are adding n times, because here n is from 1 to n. Then it becomes n into x bar square or not. Now if we apply the value of x bar here, this will be sigma xi square, it is 2 into sigma xi upon n into sigma xi plus n into, this is sigma xi upon n whole square. Can we write this as 1 upon n sigma xi square minus 2 into sigma xi whole square divided by n plus n into sigma xi whole square divided by n square or not? And here this n cancels the square. And now if we take the LCM here n, this will be 1 upon n square, n into sigma xi square minus 2 sigma xi whole square plus sigma xi whole square. Now this can be subtracted. Minus 2 plus 1, that will be minus 1. So this becomes 1 upon n square, n into sigma xi square minus sigma xi whole square. This becomes the formula to find out the variance, and the standard deviation, as we know, is the positive square root of it. So we could convert the same formula into another formula where we are not applying x bar. Now suppose the frequencies are also given. This is the frequency distribution. Then what will be the change in it? Let's see. The formula which we have obtained now is variance sigma square is 1 upon n square, n into sigma xi square minus sigma xi whole square. If we multiply this n square inside, can we write this as 1 upon n sigma xi square minus sigma xi upon n whole square or not? Which can be written as 1 upon n sigma xi square minus x bar whole square. So this also becomes the formula for the variance. And standard deviation, as we know, is the positive square root of the variance. Now in case we are given the frequency distribution, so for frequency distribution, the same formula sigma square can be changed by multiplying the frequency with these two. So the formula will become 1 upon n square, n into sigma fi into xi square minus sigma fi into xi whole square, where we know that n is sigma fi, that is the sum of the frequencies. Now in case we are finding xi is very large, then we can reduce it to the shortcut method. By applying the shortcut method, we know that generally what we do, we take one of the number as assumed mean A, and then we write xi minus A as di, that is the deviation. If we apply the deviation here, then the value of sigma square, that is variance, will be 1 upon n square, n into sigma fi into di square minus sigma fi into di whole square. Since we are taking assumed mean as A, this is also known as change of origin, as the origin has been changed from 0 to A. Now if we are finding di also is a bit large, then we can divide this di by the class interval or the HCF of all di, and in that case we write xi minus A upon h is equal to di upon h, and this we represent by ui. In that case, sigma square variance becomes 1 upon n square, n into sigma fi into ui square minus sigma fi into ui whole square into h square y, because we are dividing this by h and these both are squares. So we have to multiply by h square. We can also say only this part as sigma ui. We can say sigma ui square. This is this part only. And if this is the part 1 upon n square, n into sigma fi into ui square minus sigma fi into ui whole square. In that case, we can say that sigma square, that is for xi, will be equal to sigma ui square, that is variance about ui, into h square. This is known as change of scale. It means in this particular part we have changed the origin as well as the scale. So we can reduce the calculations to the simple form by applying change of origin and change of scale. We have to remember here one thing, that in case we are changing the origin, there is no change in the variance. But in case we change the scale, then we see this relation that there is a change in the variance. And if we multiply that by h square, then only we get the actual variance of the given data. We will discuss now some problems based on the same. Now we discuss one problem to find out the variance and the standard deviation of a given frequency distribution by using change of origin. And here the data are class intervals from 0 to 30, 30 to 60, 60 to 90 and so on, from 180 to 210. The frequencies of this are given 2, 3, 5, 10, 3, 5, 2 respectively. And the sum of all these frequencies is 30. So n, which is sum of frequencies, is equal to 30. Then we know that we have to find out xi, and that is the class mark of each class, and that is given by u plus L divided by 2. We have already learned that in the previous videos. So here it comes as 0 plus 30 divided by 2 is 15, 30 plus 60 divided by 2 is 45 and so on, 75, 105, 135, 165 and 195. After finding xi, from these xi only we have to consider one of the assumed mean, that is A. And here suppose A is the value 105. We are taking, let the assumed mean A be 105. Now we have to find out the deviations from this A. That is xi minus A, or we call it di. And here it comes as 15 minus 105 is minus 90, 45 minus 105 is minus 60, and so on. We have got all the di's. After finding the deviations, we have to multiply these deviations with the frequency, that is fi into di. And it comes as 2 into minus 90 is minus 180, 3 into minus 60 minus 180, 5 into minus 30 minus 150, 10 into 0 is 0, 3 into 30 90, 5 into 60 is 300, and 2 into 90 is 160. And if we add them all, the sum comes as 60. Now we have to find out di square. And the square of minus 90 is 8100. That of minus 60 is 3600. That of minus 30 is 900. That of 0 is 0. 30, that is 900. 60, the square is 3600. And the square of 90 is 8100. Now we have to multiply this di square also with the frequencies. That is fi into di square. Here it comes as 2 into 8100 is 16200, and so on. We have got all, and the sum of them comes as 68400. Now we know the formula for finding the variance is 1 upon n square into n into sigma fi into di square minus sigma fi into di whole square. Substituting the values, we get 1 upon 30 square, because n is 30, into 30 into fi into di square, sum of that is 68400, minus sigma fi into di is 60, so the square of 60 here. Simplifying this, we get 1 upon 900 into 30 into 68400 minus the square of 60 is 3600. Now we can take here 30 into 10, 300. From this also 300 can be taken as common. So we are getting 1 upon 900 into 300, and here it comes as now 6840 minus 12 into 336, so it comes as 12. 300 cancels this 3 times. So it comes as 1 upon 3 into, subtracting this, 6828. And when we divide it, this comes as 3 to the 6, 3 to the 6, 3 7 the 21, and 3 6 the 18. This is 2276 is the variance of this data. Then the standard deviation, that is sigma, will be root of 2276. On calculation, it comes as 47.7 approximately. Like this, by changing the origin, we can find out the variance and the standard deviation of the distribution, and there is no change by changing the origin. Now we discuss the same problem by changing the origin and the scale both. The problem is same, class intervals are here, frequencies are here, and the sum of the frequencies is 30, so sum of the frequencies n is 30. Here class interval h is also 30. Now we find xi. Xi we know is the mid value or the class mark, and that also we have found earlier, that is 15, 45, 75 and so on. Then we find the value of A, the assumed mean. Here also we are taking, let the assumed mean A be 105. In that case, we have to find out di, that is the deviation from A, xi minus A. And it is minus 90, minus 60, minus 30, 30, 60, 90. The same as we got earlier. Now, in case we divide this di by h, then we can see here 90 divided by 30 is 3, 60 divided by 30 is 2, 30 divided by 30 is 1. These are all negative. It is 0. Here they are 30 divided by 31, 60 divided by 32, 90 divided by 33. So you can see here the values have been reduced. They are smaller values now. And now we find it easy to square and multiply with the frequencies. So in this case we are finding Fi into Ui. That is 2 into 3 minus 6. 3 into minus 2 minus 6. 5 into minus 1 minus 5. That is 0. 3 into 1 is 3. 5 into 2 10. And 2 into 3 is 6. And if we find the sum of them, that comes as minus 6 plus 6, that is 0. Generally, the sum of deviations from A comes as 0, or sum of UIs. And the sum of Fi into Ui comes here as 6, 6, 12, 17, minus 17 plus 19, that is plus 2. Now we have to find out Fi into Ui square. For that we see here 2 and Ui is minus 3. Square of minus 3 is 9, 9, 2 is 18. Minus 2 square is 4, 4 into 3 is 12. But instead of doing that, we can also see here this is Fi into Ui and Ui is here. If we multiply Fi into Ui, then also we will get Fi into Ui square or not? This is the shortest method of doing this. So we can multiply 6 into 3, that is 18, minus 2 into minus 6, 12, minus 1 into minus 5, 5, 0, 1, 3 are 3, 2 into 10, 20, and 3 into 6, 18. And when we add them, we are getting the sum as 76. Now we know the formula to find out the variance, sigma square, that is 1 upon n square into n into sigma Fi into Ui square minus sigma Fi into Ui whole square into h square. Substituting the values we see here, 1 upon n is 30, 30 square, into n 30 into Fi into Ui square is 76 into 76, minus Fi into Ui is 2. So sigma Fi into Ui square becomes 2 square into h is 30, so this becomes 30 square. While simplifying it here, this 30 square and 30 square cancel. And then on simplification we get here 30 into 76, this is 0, 3, 6, 18, 2, 2, 8, 0, minus square of 2 is 4. It comes as 2, 2, 7, 6. So we are finding the same value as we obtained earlier. And then standard deviation sigma is root of 2276, which is approximately 47.7. Like this, by changing the origin and the scale, we find the calculations become easy. But we have to remember that h square is to be multiplied here. If we are not multiplying this, the value will come as 1 upon h square. And that is why we say that sigma square, that is variance, is equal to sigma ui square into h square. Only this value can be called as sigma ui square. So in this video, we have learnt how to find out the variance and the standard deviation by using the shortcut method or without using the mean. In the next video, we will learn about the quartile deviations. Thanks for watching the video. If you have any comments or doubts, leave them in the comment box and I will get back to you.